Parallel series circuits in AC. Fundamentally, it's not much different from DC circuit analysis. It uses complex numbers to represent voltage, current, and impedance. That's the only difference. You need to know Ohm's law, Kirchhoff's current law, and Kirchhoff's voltage law. Also an understanding of complex numbers. You need to know how to calculate the reactances in a capacitor and an inductor. The formula is shown along with how to use them. The frequency is given with the source voltage of the AC. This will help you greatly in analyzing the circuit. Remembering that an inductive reactance translates to a positive imaginary impedance of positive 90 degrees, while a capacitive reactance translates to a negative imaginary impedance of minus 90 degrees, resistance of course is still purely imaginary, so polar angle of 0 degrees. In order to solve parallel series AC circuit, you need to know how to add impedance in series and parallel. This will help you greatly in finding total impedance. Now, let's try solving an example using what we know so far. We need to determine the impedance of the components, and then by that, find the current and voltage drop across each of the components. By using the formula shown before, we found the impedance across each component. Now, we have to find the total impedance using the method written out on the screen. Since we now found total impedance using the formulas, we can find total current using Ohm's law, V equals IR. Since C1 is in series with all the other components, we can see that it must equal to the source voltage. By using Ohm's law again, we find that the voltage across C1, and using Kirchhoff's voltage law, we find the voltage drop across R. Now that we know the voltage across R, using Ohm's law, we can calculate the current going through R. And then, using Kirchhoff's current law, we can calculate the current going through L and C too. Finally, we can then calculate the voltage across L and C too using Ohm's law again, V equals IR. Congratulations, now you know how to solve a parallel series AC circuit.
Created using Powtoon.